Hello, good morning to all. I am Dr. R. Krishna Sharma. I am going to handle a lecture on solid state physics for third BSc physics students, especially the unit that includes nanotechnology, synthesis and characterization of nanomaterials. So this covers the synthesis of nanomaterials, classification of nanomaterials based upon the confinement, one-dimensional, two-dimensional, three-dimensional confinement of the materials, synthesis of nanomaterials, their characterization, properties, applications of nanomaterials, and we will be moving on to called as fullerenes or buckyballs and explore carbon nanotubes, their application, properties. First of all, what do you mean by nano? Nano is a Greek word which has a meaning of daf, small. So the value of 1 nanometer is 10 power minus 9 meter. So whenever we decrease the size of the materials and we get the size in the order of 10 power minus 9 meter, then the scale is called as nano. So these materials are finding different applications when compared to that of bulk materials, and therefore the study of nanomaterials become more important. Those materials whose size lie in between 1 nanometer to 100 nanometers are called as nanomaterials. The nanoscience and technology deals with the synthesis, characterization, exploration and exploitation of these materials. Nowadays, this nanotechnology plays a vital role in all fields. Exceptionally very good in the case of medical industry, where people have introduced nanorobots for cancer treatment instead of chemotherapy and carpet bombing techniques. These robots will carry medicine and deliver the drug to the particular site where the tissues or cells are to be killed without causing any harm to the surrounding tissues and cells. In the case of industries, nanotechnology plays a vital role, and it is finding application in many aspects and many fields. In the case of synthesis, there are two sorts of application synthesis process. One is top down, other thing is bottom up. Top down, it is called as top down because we start from bulk materials and we get the desired value of nano-sized particles. So in this process, the starting material will be a bulk form. The bulk material will be crushed down into larger number of smaller particles and further crushed to attain the materials or particles or to have a nano size, that is 10 power minus 9 meter of the order. So in top down process, a bulk material is crushed down into fine particles using the process like mechanical alloying, which primarily has ball milling, where you will have a large sized ball in which the bulk material is laid down and it is crushed into a fine particles by mechanical process. Then you have sputtering using high powered laser ablation, photolithography, etc. The other technique is bottom up approach, where the materials are prepared by arranging the atoms from smaller scale, that is building these atoms one upon the other to get the desired structure or desired size of the materials. And this method is desirable because the nanomaterials of desired shape and size can be obtained when compared to the top-down process, where it is difficult to control the structure of the material. So bottom-up is always better process, which involves chemical vapor deposition, sol gel and electrode deposition. So this is the pictorial representation of top-down and bottom-up, where top-down, the starting material is the bulk form, and where in bottom-up process, the starting material is atom by atom, assembly of atoms to get the desired size. So these are the sketches of nanocrystalline materials. The first figure gives you crystalline with vacancy, second thing is nanocrystalline, and third form is amorphous solids. And depending upon the confinement, you can classify the nanomaterials as one-dimensional confinement, two-dimensional, three-dimensional, etc. One-dimensional confinement. In the three dimensions, if any one of the dimension is confined and the particles are allowed to move in other two dimensions, it is called as one-dimensional confinement. If the two dimensions are confined, it is called as two-dimensional confinement or one-dimensional material. If all the three dimensions are confined, it is called as three-dimensional confinement or zero-dimensional material. The example for one-dimensional confinement is a quantum well. Example for two-dimensional leads to nano wires, nanotubes.